Last time we talked about solid rocket engines. Today we're going to talk about how we use those solid rocket engines in boosters. Solid engines have a very simple design. They provide a lower exhaust velocity than liquid propellant engines. They're easy to store and they can be used immediately. And they help provide thrust when launching. So you can put a solid rocket engine or a booster on a main rocket to provide a little bit more thrust to get off of the ground. So the most classic example of this are the solid rocket boosters on the space shuttle. The solid rocket boosters are these two white things on the sides here, as we're indicating. Then the orange thing is not actually like a rocket engine. That's just storage tank for the hydrogen and for the oxygen. And then the space shuttle itself is the shuttle-looking thing there. The SRB, the solid rocket boosters, are relatively simple in that they're just sort of this casing that has all of this rocket fuel actually packed into it. And the main issue with the solid rocket boosters is they're so big that you can't actually build them all in one giant piece. You build them in many pieces and then you assemble those pieces. So how do they separate from the shuttle engine? So what happens here is that the solid rocket boosters actually help the shuttle get off of the launch pad and they help it get up into near space. And after about 100 seconds, 110 seconds, those solid rocket boosters detach from the main fuel tank and they go off to the sides. And then after a while, the fuel tank detaches also. And then what happens is that they have parachutes and they come down into the ocean. And then a boat goes out and it gets those solid rocket boosters and it brings them back and they reuse them. They take them all apart and they repack them with solid fuel and then they reuse them. So here is a picture of the different components coming together. So like I said, there are like lots of components that are stacked together. There are 4 main areas or sections of the solid rocket boosters that are filled with the solid fuel and they're put together. How they get put together is really important. You basically build these things together in parts and then they come together and they fit together with this really tight fitting. The upper part is called the tang and the bottom part, which is the receiver part, is called the clevis. Those come together and they do not make an airtight fit. They basically just put these things together and then bolts go through them to hold them together, but it is not an airtight fit. And so the way to do an airtight fit is that you have these things called O-rings, which are these rubber gaskets which go all the way around. And as the rocket fuel is burned, that rocket fuel can't go around the tang through the clevis to get out. And those O-rings basically make that seal to make it so the rocket fuel can't exhaust out that way. And that's really important because one of these O-rings failed and that caused one of the space shuttles to be destroyed. So there's a lot of generation in NASA rockets. There was the Saturn V, which is the biggest rocket ever made. There's a space shuttle. And then there's this new thing called SLS, which is the Space Launch System. The Space Launch System is going to use solid rocket boosters, which are similar to the solid rocket boosters that were used on the space shuttle. Solid rocket boosters are very useful, and they help get massive rockets off of the launch pad. Other rockets use them too. So the Delta IV rocket has used solid rocket boosters in the past. So Delta IV rockets are part of the United Launch Alliance, which is this big alliance of rocket providers, which is responsible for launching a lot of stuff into space. The Delta IV rocket started in the early 2000s, and they joined the United Launch Alliance in 2006. And they used solid rocket boosters to provide more thrust on launch. The Delta IV Heavy now actually uses liquid boosters instead of solid boosters. You can see that the bottom 3 stacks actually have a lot of exhaust coming out, which is super cool. And you can see that the 2 side things are the boosters, and they look amazingly like the center thing. And that basically allows them to build this at a cost-effective way. In the future, there's this thing called the Vulcan Centaur rocket, which is also a big rocket which will be used to get very large things into space. And that is the Delta IV and the Atlas replacement rocket. It is a heavy lifter. It's going to be used primarily for military and for things that are very, very, very large. And its first launch is scheduled for 2023. And the core system with no boosters can take about 10,000 kilograms to low Earth orbit. But if you put on 6 solid rocket boosters, it can take 27,000 kilograms to low Earth orbit. So you can see just by adding some boosters, you can get a lot more stuff to low Earth orbit. The Falcon Heavy, which is SpaceX's heavy lifter, does not use solid rocket boosters. It uses liquid-fueled rocket boosters also. And they did it this way to save cost in manufacturing. So what they do is you could sort of see that the 2 things on the sides are the boosters, and they look, once again, amazingly like the center thing. And the center thing is a Falcon 9. It is the first stage of a Falcon 9. So they take 3 first stages of Falcon 9s and they strap them together. And the reason they do this is because instead of creating like one center thing that you have to manufacture in one way and then 2 side things that you would manufacture in a totally different way, you can just take 3 things that are all manufactured in exactly the same way, and you can save a huge amount of money in the manufacturing costs. So they're liquid fueled. The 2 side Falcon 9 boosters are liquid fueled, just like the center one is. And that reduces manufacturing costs. So in summary, boosters allow rockets to carry more payload into space. They are often solid rocket engines because those are very easy to build. But a lot of companies have turned to using liquid boosters. But NASA is actually using these solid rocket boosters for the space shuttle back when the space shuttle flew, and they're using them for the new Space Launch System, SLS. SpaceX and other companies are actually using liquid boosters that are the same as the main rocket to basically cut down on manufacturing costs. Instead of building one central body and then 2 boosters that are completely different, they can use these reusable Falcon 9s and then strap them together, and it saves a lot of manufacturing costs.